All right. So let me see. Right now, I'm mute themselves. Right. Um, no real major announcements. We're at the end of week 5. Well, towards near the end of week 5. So we're just going to kind of keep working through section 1.4. Um, just be aware that we do our lab component is going to consist of Alex, right? So that's going to be 10% of our overall grade. If you already have an Alex account set up, you can just use the one that you have from the summer, and just keep working on whatever you already have in your account. If you don't have an Alex account already set up, I think we took time on Tuesday to get everybody in, so that everybody should be in there. Um, so yeah, hopefully, that's where we are. Anybody have any questions they'd like to ask? Feel free to unmute yourself. Once we get going, then we're going to use the chat going from once we get going.
I have a question about attendance.
So if you got attendance credit for that day, it should not have gone down. Like you should have got credit for that day. Like once I take attendance, I don't make a big deal after the rest of that. Like once you take attendance, then it's set for the day. Okay, so yeah, so if you get booted, it's okay. What's a good idea is to have like the contact of a few of your classmates, a few of your brothers, and if you do happen to get booted and you wanted to get back in, just text them and they'll let me know in the chat, and then I'll unlock it for you to get back in. But yeah, once I take attendance, I don't go back and like undo it. Like it's fine. It's totally okay.
Professor, when do you want us to start working on Alex?
As soon as possible. Yeah. So I think we streamed that whole discussion from last time. It should be on last class session, the session from last class. Yeah. So you just want to get started on that, and I think we talked about how many we expect you to do. The baseline for everybody at least needs to be doing about 25 lessons a week. If you're in the prep for intermediate algebra, you need to be doing about 35 lessons per week, and if you're in the prep for basic algebra, you need to be doing about 50 lessons per week. Because the goal is for everybody to be finished at or above prep for college algebra by the end of the semester. All right, that's the goal. And my colleague is going to grade that on a weekly basis, and she's going to send me a report. And whatever grade she has on her report, that's what I'm going to use to count as our lab grade. And I'm going to have the lab count as 10% of our grade. Okay. All right. Let me see. Let me get to where we left off last time. You're doing that thing. Okay. So reload you. I'm gonna go ahead. We don't need to do that just yet. So again, I'll be monitoring the chat. I feel like I've kind of worked out the kinks with this whole system. So a smoother presentation and like without all, because I was like, I know there's a way for me to do this without having like all the, sidebar and all that kind of stuff. I'm gonna move this to the. I think it's fine where it is actually. I think it's fine. But yeah, I feel like there's something else. The main thing is just be doing our assignments on Pearson and submitting our assignments via for Alex. If your Pearson code has run out, you want to get full access as soon as possible. Oh yeah, let me update this thing. These guys I don't see. So I'm only missing about 3 students. So it's not bad. Okay. Yeah, the main thing is just be sure to get full access to Pearson. And we essentially get unlimited attempts on all of our assignments. Even if they're late, it's only a 10% late penalty. So if you really want an A on assignment, I mean, any assignment, honestly, you can earn it. You just have to, just push and you can get it. You can, honestly, anybody can get whatever score they want. Like you just got to just go and get it, really. It's just sitting there waiting for you. Let's pick up where we left off. I think I was scrolling. Are you doing it again? You still acting up? Yeah, a little bit. Let's try it. Let's refresh it one more time. Let's close some of these windows. I think that'll help as well. Let's get rid of this stuff. Let's open this back up. We're here, and it should work better this time. Okay. So when we left off, I think we left off here. Nope, that wasn't where we left off. We left off. It should have been. Here it is. Yeah, this is where we left off. Okay. So we were successfully able to graph a piecewise function. We really only need to do. So if we have 30 to about slide 45 is as far as that we need to go. We can go to the end. We'll kind of play it by ear, but at least we need to get to about slide 45. If we finish the notes today, then we can take all of Friday as just a study session, like working on Alex and or the homework, anything, either of those that you want to work on. But it depends on if we finish the lecture today or not. So we made a note to start here today. Okay. So we're asked to graph the greatest integer function. So this didn't display properly, so we got to get it to display properly. First, let me start with the box. So the greatest integer function is actually supposed to look like the following. It's like a square bracket, x, square bracket, but then it has this extra bar like this. And so this is the greatest integer function. And so the greatest integer, we want to take the all of our results collapse to the greatest integer less than or equal to our value. All right, let's see it in action. Let's copy this. Okay, and all of these have to be replaced. Like that one. This one. That's right. So again, the greatest integer function. So for instance, say our x was somewhere between 2 and 3, right? Say x was 2.5, right? Then the answer is gonna collapse to just 2. Say x was 2.9. Notice 2.9 is between these. This answer is still gonna be 2. Okay. Say x was between 1 and 2. Say x was like 1.1. The answer is gonna be 1. Say x was 1.00001. So it's slightly to the right of 1, the answer is still 1, right? So if we take our x and whatever two integers the x is between, the answer is going to be whatever the integer to the left is. Okay, that's the greatest integer function. It's kind of like a floor function. Let me pull up the chat. Thank you. Okay, let's keep going. And so the graph of the greatest integer function is going to look something like this. All right, so this is called like a step function. Okay, and it just basically has this shape. So then the following are going to be some common functions of algebra along with their properties and should be included in a library of basic function. All right, so this is just going to be a collection of basic functions that we're going to introduce so that we can start graphing functions. And so we're going to build on top of these basic functions. So the first is the constant function. It's just y equals a number, right? So if we had a graph like this, and feel free to type your responses into the chat. Can anyone tell me what's the domain? What's the very left to the very right? What's the domain of this? How far left does the graph go? How far right does the graph go? Right? So the domain here would be negative infinity to infinity, right? The very left or all reals, yep. To the far right, right? Okay, can someone tell me the range? How far down does this graph go? Notice it's a flat horizontal line. So what's the smallest y value? What's the largest y value? What's the range? C, right? Just C. So the very bottom, the y value here is C. The furthest up that it goes is also just C. So neither does it go up nor down. It's just that one y value. So the range here is going to be just the number C. Curly brackets is like a discrete set, which means just the number C. As we trace it left to right, is this function increasing, decreasing, or is it constant? As we trace it left to right, is it increasing, is it decreasing, or is it constant? All right. So it's staying flat, right? So it's just constant. So we would say this function is constant over the entire domain of all reals. Do we have any kind of symmetry going on here? Is it symmetric about either the y-axis or the origin? Is there any kind of symmetry going on? Right. Notice we can fold this on the y-axis and the two halves are going to match up. So this function is going to be even. The definition of even means if we did f of negative x, that's going to give us f the original, f of x, right? So that's the definition of a function being even, and in a graphical sense, it means y-axis symmetry. So that's going to hold, both of those are going to hold here, right? So the domain is all reals. The range is just the number c. It's constant over the entire domain, and this is an even function, which means we have y-axis symmetry. Okay, what about this one? Can someone tell me about the domain and the range of this one? The hint is they're the same here. Yeah, all reals for both, right? So the domain being the very left to the very right. So no matter how far left we go, we can find the corresponding y with each x. No matter how far right we go, we can find the corresponding y with each x, right? So the domain is all reals. The range is similar. No matter how far down we go, we can find a corresponding x to our y's. And no matter how far up we go, we can find a corresponding x with our y's. Right? So both the domain and so every x is accounted for, every y is accounted for. So we would say both the domain and the range are all reals or negative infinity to infinity. As we trace this left to right, is this increasing, decreasing, or constant? As we trace it left to right, is it increasing, decreasing, or constant? So this is increasing. This is increasing over the entire domain, right? Increasing over the entire domain. Do we have any kind of symmetry going on? Is there any either y-axis symmetry or origin symmetry? Is there any kind of symmetry going on? There is. So there is origin symmetry, right? Origin symmetry, whenever we have x comma y, we also have negative x comma negative y. Another way you can look at origin symmetry, if you put your thumb on like, let me put this on the charger. If you put your thumb, hey Google, turn the fan on.
Sure, turning on fan.
All right. Just charge a little bit. Okay. So yeah, origin symmetry, right? So like if we would put our thumb on the origin and rotate the top half 180 degrees, they're gonna match up, right? So I kind of like to consider origin symmetry like rotational symmetry. But again, whenever we have x comma y, we also have negative x, negative y. And the definition of odd means if we do f of negative x, we get negative of the original, so negative f of x, right? So I think we've spoken on those. We see the domain and range. We see that it's increasing over the entire domain. And the function is odd, which means we have origin symmetry. Okay. What's the domain of this function? The very left to the very right. How far left is this graph go? So the very left, so the domain here is all reals. Can anybody tell me the range? How far down? What's the very bottom to the very top? How far down does it go? Yeah, 0 to infinity, right? The 0. So do we include 0, yes or no? Do we include 0, yes or no? How do we know it's all reals? Okay, so you might be tempted to say, oh, from -3 or -4 to 4, but you kind of do have to use your imagination. So, like, you ask yourself, oh, is it possible for x to be -4? Yeah, because if we let x be -4, then the answer is going to be what? 16. So keep in mind, these graphs, we can't show the whole thing in our human limitation. You have to know that the arrows mean continue the pattern forever in those directions, all right? So no matter how far left we go, we can find the corresponding y. No matter how far right we go, we can find the corresponding y. All right? So we do kind of have to use our imagination and realize that the parabola continues to open. So, like, for instance, if x were a -1 million, yeah, it's going to be there. We just have to go way, 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 way up to find the corresponding y. It's going to be really high, whatever 1 million squared is. You know, that's how high we're going to have to go to find it. But we can find the corresponding y, right? And then for the range is the very bottom to the very top. So if we look at our y values, the smallest y value is 0. The largest y value goes off to infinity, right? And so I asked the question, do we actually reach 0? Do we include 0? And I got a couple of yeses, and I will agree with that. We do include 0. Can you tell me what kind of grouping symbol will the 0 get? If we do include 0, is it going to be a square bracket or a parentheses? It will be a bracket, right? So the bracket, that's the curly bracket. Curly bracket is different than square bracket. Curly bracket just means a discrete set. It just means just those numbers, right? Versus a square bracket means, okay, we include the endpoint and we include all the decimals and fractions that are close to it as well. Curly bracket will be just those specific numbers that you see, right? So this will be a square bracket. As we trace it left to right, is it increasing, decreasing, or constant initially? As we trace it left to right, is it increasing, decreasing, or constant? Is decreasing then increasing? I can agree with that. So if it's decreasing initially, over what part of the domain is it decreasing? So what's the far left that is decreasing? How far left can we go? Way out in left field. What's the far left? Okay, yeah. So we say that this function is decreasing from negative infinity up to 0. And then from 0 to infinity, the function is increasing again. All right. Do we have any kind of symmetry going on? Either y-axis symmetry or origin symmetry. Any kind of symmetry here. We have any kind of symmetry going on. Y-axis symmetry, right? So notice, visually, we can fold it on the y-axis and it'll match up. If we wanted to do a test for symmetry, we can, like, if we wanted to test for even or odd, we would do f of -x, and in this case, we should get back f of x. So if we do f of -x and we get back the original, that's the definition of a function being even, which is the same as y-axis symmetry. Okay? I think we mentioned that we went over everything there. Let me at least get to the end of... that was weird. Let me at least get to the end of this. My teeth are doing something weird. It's weird. Anyway. So the domain of this one, Mr. Ephraim. What was your question, Mr. Ephraim? I don't see a question. Oh, okay. So we would use union to, let me see, connect, convey that. No. Let's go back. Right? So we would say that it's decreasing from negative infinity to 0. That's just one answer by itself. And then we would say it's increasing from 0 to infinity. That's a different. That's a different. That's a whole different thing. Right? So we're not going to use union here. Okay. Let's keep going. So if we have this image, the domain, so the very left to the very right, if you had to guess, what would you guess? So the very left to the very right, all rows, right? Okay, can you tell me the range? Same thing, right? Okay. So both the domain and range, no matter how far left we go, we can find the corresponding y for our x. It's the same across the board. So domain and range here, they're both all rows. As we trace it left to right, is this function increasing, decreasing, or constant? If you had to guess. So this function is actually increasing, right? As we trace it, as we trace it left to right, it's going to be going up and up and up. It looks like it flattens out at 0, but it actually doesn't. If you were to zoom in, you would still kind of see the slope a little bit, right? And it never turns and like comes back down either. So it's increasing over the entire domain. So from negative infinity to infinity. Is there any kind of symmetry going on, either y-axis or origin symmetry here? Any kind of symmetry? So we do indeed have origin symmetry. So the definition of a function being odd means if we do f of negative x, we get negative f of x, right? A function being odd is the same as origin symmetry. So that means whenever we have x comma y, we also have negative x comma negative y. Okay? All right, I think we got all of those. Domain and range, increasing over the entire domain. The function is odd, which means origin symmetry. What about the domain of this one? From the very left to the very right. Okay, tell me about the range, the very bottom to the very top. Okay. What kind of grouping symbol is a 0 going to get? It does get a square bracket. I feel like I'm actually talking to the computer. It feels kind of weird because it's so quiet and I'm just reading the chat. It's like I'm asking the computer questions and it's like it's talking back to me. It's kind of creepy. How much wood could a woodchuck chuck if a woodchuck could chuck wood? Why doesn't the 0 get a parentheses? Okay, so parentheses means we get really close to that thing, but we don't include it, right? But in this case, it is defined when x is 0. Absolute value of 0 is 0, right? So we can include 0. So then that's why it gets a square bracket. Right? These are good questions. Right? Okay. Okay, tell me about increasing, decreasing, or constant. As we trace it left to right, tell me about is it increasing, decreasing, or constant? It's like the computer's thinking. Processing. Oh, we got guts. We got lulled into a false sense. Okay, yeah, that's a little bit better, right? Decreasing, first is decreasing, and then it's increasing, okay? So it's decreasing over what part of the domain? What's the far left? Far left up until where? It's similar to one from before. Right? So we say it's decreasing from negative infinity to 0, and then it's increasing from where? 0 to infinity, right? Okay. All right. So this looks good so far. Hopefully this is making sense. Is there any kind of symmetry? Either y-axis symmetry or origin symmetry. Tell me whether it's even or odd. Is this function even or odd? Okay, so there's y-axis symmetry. If there's y-axis symmetry, is the function even or odd? Even, right? So evenness is not synonymous with y-axis symmetry. Okay. These are the kind of questions I would ask if like we were doing an oral exam. I would just kind of go just like this. This is about the rhythm. Okay. So I think we got the domain, we got the range. We said decreasing, increasing, even. Okay. So this is called the square root function. So these are all basic functions, like the basic shapes of general functions. And then we're going to be like graphing based on these and like introducing ways to graph using transformations and things. Can you tell me about the domain of this? And as a hint, I'll go ahead and say that the domain and range are similar here. Tell me about the domain. Yeah, 0 to infinity looks good, right? So both the domain and the range, in this case, they're both 0 to infinity. The possible x values take on 0 to infinity. The possible y values take on 0 to infinity. Is this function increasing, decreasing, or constant? It's increasing over the entire domain, right? So when we start from the far left, which is 0, over to the far right, which is positive infinity, the whole time going from the left to the right is increasing. Is there any kind of symmetry here? Is this either even or odd or neither? Any kind of symmetry here? I wish I had stopped at the first question. It's neither, right? It's neither even nor odd. Okay. Let's see. These just kind of keep going. I think we got all of those. So this is the cube root function. This is just what a cube root looks like. Okay. I'm just going to kind of let that be. This is called the reciprocal function. Okay. So let me kind of make this disclaimer. So the reciprocal function, it has the general graph has two asymptotes. It has a vertical asymptote, which is the y-axis, and the horizontal asymptote, which is the x-axis. So with these asymptotes, what happens is, like, for instance, as we go off to plus or minus infinity on the x-axis, our graph gets really, really close to the x-axis, but it never really crosses or touches the x-axis, right? As we go off to, as we get closer and closer to 0 on the x-axis, y goes off to plus or minus infinity, right? But we never really touch the y-axis, right? So if we have these things called asymptotes, a vertical and a horizontal asymptote, can you tell me the domain? What are the possible values that the x can take on? If we think about the domain here, what's the very left to the very right? Or in other words, if we were to take this graph and smush it onto the x-axis, what are the possible values that x can take on? Everything except 0, right? Tell me about the range. The range is basically a similar discussion. If we were to smush this onto the y-axis, every y would be accounted for except y equal to 0, right? Because of those asymptotes. Right? So the domain will be everything except 0. The range will be everything except 0. And this is actually a case where we would do negative infinity to 0, parentheses, union, parentheses, 0 to infinity. And we'll see it in just a moment. But this is a case where we would combine the left and the right sides together using union. Okay, tell me about whether this function is increasing, decreasing, or constant. Is this function increasing, decreasing, or constant? As we trace it left to right, what is it doing? It's decreasing, right? So we say that this is decreasing over the entire domain. As we move from the left to the right, it's going down. Is there any kind of symmetry here? Is this either even, is this function even or is it odd? Is the function even or is it odd? Okay, yes, odd meaning that it has origin symmetry. Whenever we have x comma y, we also have negative x, negative y. To do the test, we would do f of negative x, and we're gonna finish with negative f of x, right? So that's the definition of a function being odd, and we can see all that here. So we see the domain and the range. We see it's decreasing over the entire domain, and it has origin symmetry, or we say that the function is odd. This is good. We went way beyond where I really intended to go today. We can do this one. Ouch. Is it still saved? Okay. I knew it was going to do that. Okay, so again, this is the greatest integer function. This is a step function. Okay, so let's try this one. Tell me about the domain. If we were to take this step function and smush it onto the x-axis, is there any x's not accounted for? Tell me about the domain. Any x? Is there any x that's not accounted for? Is there any x that we can't find the corresponding y value to? So in other words, tell me about the domain. So the domain. So if we were to take this function and smush it onto the x-axis, every x is going to be accounted for. So the domain here would be all rows. All right. Tell me about the range. What are the possible values that the y values take on? Okay. I hope we're not reading. You know. I hope we're not reading. Because I mean, if you're reading, that's fine, and that, I don't even really knock that. I'm not saying that you are, because that's not an obvious question. That's not obvious. But it was just an exercise to see, can we visualize? Because when we get an application, we're not going to have anything to read from, right? So you want to try to. But others were all kind of the same kind of deal. So with this one, if we were to take this and smush it onto the y-axis, right? Notice like the fractions, like y equals a half or 1.5, all these fractions in here, they don't correspond to, it never touches the graph anywhere, right? If we take this and smush it onto the y-axis, it does collapse to just the integers only, right? Okay. Let me see. And so notice as we trace it left to right, in all of those segments, they stay flat. So it will be constant for each segment. So we would say it's constant from like 0 to 1, and we have to use the proper grouping symbols. And I think there's no symmetry here, but I think we just answered the first couple of questions. Oh, it's neither even nor odd, and there's no symmetry, and it's constant over all of those segments. Let's go back. Okay, there's no worries though, because sometimes people don't even have the sense to just look ahead, like just to read. Ah, you've been on battery power this whole time? No worries. Boom, there you go. All the juice you get on. Let me see. Okay. Let me see the time. What time we get out? We got a good amount of time. Okay. So I think I want to stop here for today, and I want to actually use the rest of class time. We can either work on Alex. You can even ask questions from Alex, or you can work on Pearson, and you can ask questions from that as well. If you are asking questions from, say you're asking a question from Pearson, just click on the Ask My Instructor and get my attention. I'll go ahead and make it so that we can unmute ourselves. So if you're working in Pearson, just use the link, just use the Ask My Instructor, and it'll send me a screenshot. We can pull it up and we can talk about it. Let me make a note. If you're working on Alex and you have a question, screenshot it. So like if you're on a Mac, I think screenshot is Command-Shift-3. If you're on like a PC, you might have to Google how to screenshot on your device. Not a photo, but just to do a screenshot. And then email it to me and get my attention, and we can pull it up and talk about it. So let me make a note that we stopped here on Thursday, September, remember, the 5th of November, the gunpowder treason and plot. I know of no reason why the gunpowder treason should ever be forgot. Okay, today's 2020. Okay, so we stopped here. So then tomorrow, and we're right on track. So let's go like this. Start here. Start here. Friday. This will be September 18th. Okay. So we'll pick back up here tomorrow. Again, so for what I'd like to do for the rest of class, if we go until 5:05, we'll stop in the 5:50 hour. Let me see. 4:50. Hey Siri, set an alarm for 4:55 p.m.
Okay. Your 4:55 p.m. alarm is on.
So let me do it like this. Let me go ahead and share this so you guys can have a copy. And again, if you have questions, just get my attention. You can unmute yourself, and I'm here for questions really. So the recommendation: let's go ahead and work on either Alex and or Pearson. And I'm here to kind of answer questions. And we can go through anything, any of those assignments if you like. Let me see. This goes. Uh,
I emailed you, but I need a passcode,
for which one?
Alex.
Okay, give me a moment. Can you send the email again? Just like send it now. Oh, that's Dropbox.
Yeah.
I don't know Dropbox. This one, your house. This one, notes. I'm gonna go ahead and pull up this item. Is this Mr. Smith? Oh no. Where are we going? 411. Okay, I'll mark him as excused. You can see that he. I'll tell him to check. Let's see. Class starts at 3:50 today. I lock the sessions at 4:05 on Thursdays. We must use Blackboard for daily access notes. I'll mark you as excused. See you tomorrow at 4 p.m. Okay, here we go. So, Mr. Coleman Johnson, I got you. Reply. Okay. Oh, that was Smith and Campbell. Okay, I see their messages. He must be in the other class. Hmm. Yeah. Mr. Smith, are you on the call right now? Okay. Let me see. I think it'll be fine. It'll be fine. I'm not gonna if you do attendance credit, I'll go again. I'll go back and change it. Oh man, what time is it? So, did anybody have any questions? You guys okay? You making it through your materials okay? Let me go. Let's go look at the grades. Let's go see what the grades are looking like. I know how students like to be quiet. They don't like to say nothing until the last minute. And then it's too late then. So hopefully we can take advantage of this stuff early. Let's go to Pearson first. So again, my colleague is going to be grading Alex for me, and she'll be sending me a weekly report, and I'll be monitoring Pearson. Actually, I need my other account. Not that. This one. So we're at the end of week 5. Let's go to this manage. Okay. Alright, it's not too bad. Actually, it's pretty good so far. Y'all look like y'all are plugging and chugging. So I see the exams are in there. Okay, we got a couple past due. So keep in mind, we can actually submit the exam. You can still work on it even past the due date, right? Uh, okay, okay, y'all are moving and grooving. I'm not gonna make a big deal about it. A few other students, nobody else seems to be receiving attendance except for me. The code. Email me. Email me if you need a code. Ephraim. Let's see. I mean, attendance should be there. Let's go back and look at it again. Are you talking about today for attendance or in general for attendance? Today's the lab, right? Yeah, today's the lab. But in general. 50s and 60s every day. Let's see. Maybe I'm not hitting something right. Let me go. Let's look here. Attendance. My end is here. Mr. Smith. I saw his email. I changed that one. Let's see. What's today's date? Today's the 17th. Like I have attendance from last time. It's showing. At least for those that were there. I did have a good amount missing the last time on Tuesday. But yeah, we're taking attendance. I take attendance as I let you guys in, right? I take attendance as I let you in. So that's kind of how that goes. Yeah. Okay. But I'm not gonna let. I mean, if you make it clear that you want to be in the class, the main thing is that as long as you like really get your assignments in Pearson, we can kind of work out the rest of that. Really, just do the best you can with attendance because it's remote, so we're still trying to work out kinks there. But the main thing is that if your stuff is in Pearson and you get your Alex in, we really can work out the rest of that. But just do your best to kind of be in class, right? Try to make your presence known. Because, like, I mean, you kind of see the same names in the chat, right? Of people responding when I'm asking questions. And that just gets you to your memory. You tend to remember stuff like that as the professor. So not only, like, you not only want to get attendance credit, but you want to try to just make an impression, right? Like, answer questions, because if I keep seeing the same names, I'm like, oh, I remember, and But if I don't ever remember seeing your name, then it's a lot harder, So that's just a little. It's not really anything. But yeah, we can work on the attendance because I know that's a little bit funky. On my end, I have what I have, So, go ahead. Okay.
You got me in, Professor?
Who said that? Mr. Williams? Let me see. Is this so loud or is it unlocked?
Cause you be sending new like Zoom codes sometimes, so I'll be coming in like
Yeah. If you make it into my lecture, like, because again, I take attendance as I let you in. Let me check and make sure. Today's the 17th. Williams, come on, stop it. Yeah. Let me see. Kevin, right? Yeah, I got you.
All right, cool. You know the vibes, Professor. Appreciate it.
Yeah, no worries. So again, yeah, I take attendance as I let you guys in. So if you get into like what I've been doing over the past few sessions, instead of just calling each person, that's why I was like, okay, go ahead and update your name. So then if I can see your name, I'll let you in. That's more than enough for me. All right. So I take attendance as I let each person in. So if you get into the call, because I went on and did the waiting room.
Nah, I was saying like that's cool, but like I know you take attendance when you come in. It's just that I just keep getting 50s for them. I'm here every day, and I do communicate in the chat, so I'm not understanding why I get a 50 every day. It might have a 50 in the class for attendance and a 62 for attendance.
So then it's probably what it's doing is probably taking it's probably taking the average as well, right? So like if it says 50 today, I don't know, like. Because
they say 50 every day.
Does it say it today?
I don't know.
It might be taking.
I just know.
It might be taking the average, right? It might be taking average, and so like if you average it out, it might become that. Because mine on my end it says this, but again, don't worry too much about that. That's not. I'm not really gonna use that for anything. Like that's just for record purposes, right?
Okay.
The main thing is, the main thing is, the main thing is, like, honestly, keep coming to class and get the stuff in Pearson. Pearson and Alex are the main things. If that's there, we can work out that whole attendance thing. I'm not going to make a big deal about that too much. Just be here.
Yeah. I was going to tell you, my book, remember I had that situation with my book and I couldn't get to work? I ordered the book, but they didn't let me know that they ran out of books. So I was sitting here waiting on a book that wasn't there.
Who is they? Is it
the bookstore? So they sending me they have to send me. I had to put in a whole new order and get a new code. Like
I don't know if you can get a refund, but you can actually buy directly from Pearson, and it'll get you in there. It'll get you instant access. You won't have to wait for anything in the mail. but that's if you went directly, like you just go to the site and get it directly from the site from Pearson. It's instant access. The books are, especially with the mail and all the stuff that's going on. I mean, you can do the best you can. But again, if you're waiting on the mail, then what you have to do is make a dummy account, like make another account with use the same information but with a different email, and then you can kind of keep working. And we might be able to like transfer the work from there to your original account. All right. The main thing is to keep working and keep a log of your scores, because I think if you do another trial, it's going to lock up.
All right.
Okay.
Thank you.
Mm-hmm. Okay, so we just finished what 1.4 today. Let's see. I like this view. I guess I could do it here. Yeah, I mean we only got a few more minutes. And yeah, because I haven't done anything with grades other than I just take attendance every day, but I haven't like the grades. I'm just gonna pull them straight from Pearson. As far as homework, quizzes, and exams, I'm just gonna pull those straight from Pearson. And then only other thing I might change is factor in the lab grade for Alex. That's gonna come from my colleague. So whatever she gives me, I'm gonna factor that into 10% as 10% of our grade. Attendance is just for records. Only trouble that might come, as long as you're getting attendance, like credit every day, only trouble that might come up is like we accumulate too many absences. Then we might get booted. But if you're like, say, hey, I've been coming, and you want to be in the class, we can keep you in the class if you want to be. Sometimes students are not coming, and then like you just got to make sure to kind of sort through properly. Okay. Okay, so if there aren't any burning questions, I think I'm gonna just let everybody go, and we'll pick this back up tomorrow at 4 p.m. All right, so we'll be back same place, same time at 4. All right, thank you guys. You're awesome. I'll see you tomorrow.
Bye, everyone.
Take care.